class. We're about to start lesson 10 from chapter 6 called System of Linear Equations. As you see, my copy is not as good as the copy in your textbook. So we're actually on page 376. So it says here, graph to solve the system of equations. The equations in lessons 7 and 9 are linear equations. They have two variables, x and y, and represent straight lines in the coordinate plane. Two or more linear equations make up a system of linear equations. Solving a system of two equations means finding the values of both variables. The solution will give you the x and y coordinates of the point at which the two lines intersect. You can express this solution as an ordered pair x, y. One way to solve a system of equations is by graphing each equation using a T-chart, like those that you filled in for lesson 7 practice. Graphing a system of linear equations provides a picture of the intersection. Follow these steps to solve a system of linear equations by graphing. Set up an x and y T-chart for each equation. Find two ordered pairs for each equation. Use x equals 0 and find y, and then use y equals 0 and find x. Graph both lines using the ordered pairs that you generated in step 1. Find the point of intersection and express it as the form xy. Now they give you an example. For the first equation, they use 0 for x and then 0 for y. And then the second, they use 0 for x and then 0 for y, and then solve for the opposite variables. So with this first equation, they put in 0 for x, which means y had to be 4. And then here they put 0 in for y, which x had to be 2. So they plotted those 2 points. And then here they put x is 0, then y had to be 7. And when y was 0, that means x had to be 7/5. And they graphed those points, and then the intersection was at 1, 2. So if you went back and substituted in 1, 2 into the equation, then that will work in both equations. So let's take this one. We put in 1 for x. That'll make that 6 times 1 is 6. If we put in 2 for y, 3 times 2 is 6. 6 plus 6 is 12. So 1, 2 works for the first equation. Now we put in the second equation. 5 times 1 is 5, plus, and then y is 2. 5 plus 2 is 7. So that works for both equations. Now we come here to substitution. Now with substitution, what ends up happening is you have to get one variable by itself and then solve for the other variable. Now, I will go in more in depth in this as we go through the lesson. So let's go here. Now, if you notice here, with problems 1 and 2, they have a graph, and they want us to solve this by graphing. And then for 3 through 6, they want us to do it by substitution. And then for 7 through 10, they want us to choose whichever method that we want to use. So let me start off. I think what I want to do, well, I'm going to start off the way how it has it. So we have number 1. We have y is equal to 3x minus 15, and x plus y equals 13. So we do a T-chart or a graph. We have x, y for one of them, and then x, y for the other. Okay, so now for the first equation, I didn't give myself enough space. So I put y equals 3x minus 15. This is the xy, the T-chart for that, and then x plus y equals 13 is the T-chart for this. So here we're going to make x 0, and then the second order pair we're going to make y 0, and the same here. So we go through and substitute. So when we have x is 0, we have y equals 3 times 0 minus 15. Y is equal to a negative 15. So when x is 0, y is negative 15. Now we go to the second one. This time we're going to make y 0. So we have 0 is equal to 3x minus 15. We add 15 on both sides. and 15 is equal to 3x. Divide each side by 3, and 5 is equal to x. So when y is 0, x is 5. Okay, now let's go to the second one. We have x plus y equals 13. So when x is 0, y will have to be 13. Okay, now here, when y is 0, that means x will have to be 13. So now we have our ordered pairs. So now we're going to do a graph. Now, if we notice here, the largest amount here, we have a negative 15 with y going down and a positive 13 with y going up. So let's do this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Going down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now with the x's, we have 13 positive, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And we can go on 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, now we can graph this. So first thing we would do is 0, negative 15. Remember, we started the origin. We'll go down 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this is 0, 15. 0, negative 15. And then next we do 5, 0. So we'll go back to the origin. We'll go 1, 2, 3, 4, 5. Okay, now I don't have a straight edge with me. So I'm going to try and draw this as best I can. All right. So there's one line here. Now we go here, the second line. We have 0, 13, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then we have 13, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, now we will connect these points. Oh, sorry, I went off the page a little bit. Now, of course, my graph is a little off because I didn't have a straight edge. But as you all go through your lesson here, you can find the exact point. Let me go here. I think this to about here. So this would be 1, 2, 3, 4, 5, 6, 7, 7, and this would be 1, 2, 3, 4, 5. So I'm saying that I think that it'll be 7, 5 would be that point. So we could try it. Okay. So we put in 7 for x. So 7 times 3 is 21, minus 15 is 6. So it might be 6. So it might be 6. But let's see here. If we go down here, 7. Let's see, 7, 6. Yeah, so it's actually 7, 6. So my graph was a little off, but it's actually the point 7, 6. So now remember, you all will be using these graphs here. So you will have more of an exact point, and with a straight edge, you would get that point. So it's 7, 6. And remember, mine was slightly off because I didn't have a straight edge, but the answer is 7, 6. So we will substitute in. So we'll go to the first equation. 6 is equal to 3 times 7 minus 15. 6 is equal to 21 minus 15, and 6 is 6. So that worked for the first equation. Now we go to the second equation. X is 7, y is 6, 7 plus 13, 13 equals 13. So our answer is this 7, 6. Down to number 3, we did a graphing problem. So now we're going to go on to substitution problem. So we have 7x minus y equals 22, and 4x plus 2y equals 10. Now, with this here to do substitution, one of these variables have to be by itself. Now myself, what I would do, if I have a variable that's basically that only has 1 or -1 as its coefficient, I would use that equation to isolate a variable by itself. So here I'm going to use this top equation. So what I would do, I would add y on both sides. So you have 7x equals y plus 22. I would subtract 22 on both sides. And you have 7x minus 22 equals y. So now we have this equation where y is by itself, one of the variables. So now to do substitution, so we took this became what the first equation was. So now we're going to take this first equation and substitute it in the second equation. Because what this is saying is, wherever y is in the second equation, we're going to replace it by 7x minus 22. So we have 4x plus 2 times 7x minus 22 is equal to 10. So we have 4x, 2 times 7x is 14x. 2 times a negative 22 is a negative 44 equals 10. 4x plus 14x is 18x. Minus 44 equals 10. We add 44 on both sides, and 18x is equal to 54. We divide each side by 18, and x is 3. Now we have x is 3. Now to find y, we could take any of these, either one of these equations, this equation, or this equation. We could take any of these three equations, substitute in 3 for x, and then solve for y. I would use this equation because it'll be easier, because once we substitute in for x, whatever answer we get here would be our y. So we have 7 times 3 minus 22 equals y. So this would be 21 minus 22 equals y. 21 minus 22 is negative 1 equals y. So our ordered pair would be 3, negative 1. Now, I'm only going to do this once. I'm going to go through and substitute these values in just to show you that they work. It doesn't matter which equation you use. I'll use the bottom one. So you have 4x plus 2y equals 10. We'll substitute in 3 for x and negative 1 for y. So 4 times 3 is 12. 2 times negative 1 is a minus 2 equals 10. 12 minus 2 is 10. So 10 equals 10. So that worked for the second one. Now we could go to the first one. So you have 7x minus y equals 22. So you'll do 7 times 3 minus a negative 1 equals 22. 7 times 3 is 21. Minus a negative 1 would be plus 1 equals 22. 21 plus 1 is 22 equals 22. So our ordered pair is 3, negative 1. Now I'm going to pick one more out of this group here, and I'm going to pick number 5. Number 5, we have y equals 3x plus 15, and 5x minus 2y equals negative 26. Now what's nice about number 5 is we already have a variable that's by itself, y. So we would take what y equals here and substitute it down here in the second equation. So we have 5x minus 2 times 3x plus 15 is equal to negative 26. So we have 5x, negative 2. We'll take negative 2 times 3x, and then negative 2 times 15 equals a negative 26. So we have 5x minus 6x minus 30 is equal to negative 26. 5x minus 6x is negative x minus 30 is equal to negative 26. We'll add 30 on both sides, and negative x is equal to 4. We'll divide each side by negative 1, and x is negative 4. Now, we're going to substitute in negative 4 for x. So I take it with the top equation. We have y equals 3 times negative 4 plus 15. Y equals 3 times negative 4 is negative 12 plus 15. Negative 12 plus 15 is 3. So we're saying our ordered pair is negative 4, 3. And you could go back and check it in the problem. Matter of fact, I'll do that one more time because this will be the last problem of this group set. So let me do the first one. So y is 3 and x is negative 4. Now remember, I'm taking this equation and substituting these values for this equation. So we had 3 equals negative 12 plus 15. 3 equals 3. So that works. Now we go to the second equation. So we have 5 times negative 4 minus 2 times 3 equals negative 26. 5 times negative 4 is negative 20. Negative 2 times 3 is a minus 6 equals negative 26. Negative 26 equals negative 26. So it'll be negative 4, 3. All right, now we go down here to the bottom. We're going to pick out maybe 2 or maybe 3 problems here. So number 7, it says the directions say choose the one best answer for each question. All right, where does the line with the equation x minus 2y equals 4 intersect with the line with the equation 6y plus 5x equals 4? Now, they're basically asking us the same thing we did with the graphing or substitution. I would suggest that you do substitution. To me, and this is just my own opinion, graphing could end up not being so accurate if you don't have a straight edge. So I would go with what would be more accurate every time, which would be the substitution method. So with number 7, we had x minus 2y equals 4. And then we had 6y plus 5x equals 4. Now, even though the x and y are out of position, it's still the same process. We need to get a variable by itself. This, I think, getting x by itself would be the easiest thing. So we could take this x minus 2y equals 4, add 2y on both sides, and x is equal to 2y plus 4. So now we're going to take this, and wherever x is in this equation, we're going to substitute in this value for x. So we have 6y plus 5 times 2y plus 4, and that equals 4. So you have 6y plus 5 times 2y plus 5 times 4 equals 4. So you have 6y equals, 6y plus, not equals, 6y plus 10y plus 20 equals 4. Now, we're going to take this equation, 6y plus 10y plus 20 equals 4. We're going to combine the like terms. 6y and 10y is 16y plus 20 equals 4. We'll subtract 20 on both sides, and 16y equals negative 16. Divide each side by 16, and y is negative 1. Now, we go to either one of these 3 equations and put in negative 1 for y. I would pick this equation. So we have x equals 2 times negative 1 plus 4. X is equal to negative 2 plus 4, so x is 2. So our ordered pair will be 2, negative 1. Now, we have to go back and you substitute just to make sure that this is correct. But we did everything correct here, so our answer here would be C. So it'd be 2, negative 1. Oh, I'm sorry, it's A, not C. It's A. So it'd be 2, negative 1, which is A. All right, so that took care of problem number 7. Now problem number 8, where does the line with the equation y equals x intersect with the line with the equation y equals negative x? All right. Let's try number 8. Y equals x, and then y equals negative x. All right, so what we could do, we could substitute in x for y equals x. So we could substitute in x for y here. So x would equal negative x. Now we would add x on both sides. So that would be 2x equals 0. Divide each side by 2 and x is 0. So now we go here and we put in 0 for x in one of these equations. It doesn't matter which one. Let's do the top. So we have y equals 0. So that's it. So x equals 0, y equals 0. Our ordered pair is 0, 0. We did everything correctly, so our answer here would be C. Now number 9, it says, where does the line with the equation y equals negative 2 intersect with the line with the equation 3y equals 2x plus 3? Now this problem is actually one of the easier ones. So with number 9, we have y equals negative 2, and then we have 3y is equal to 2x plus 3. Now we're already being told that one answer of our ordered pair is negative 2 because it tells us that y is equal to negative 2. So now all we have to do is substitute in negative 2 for y and solve for x. So we have 3 times negative 2 is equal to 2x plus 3. 3 times negative 2 is negative 6 and is equal to 2x plus 3. We'll subtract 3 on both sides. So negative 9 is equal to 2x. So we have negative 9 equals 2x. Divide each side by 2. And negative 9 halves is equal to x. Now, so our ordered pair is negative 9 halves, comma, negative 2. Because we were given that y is negative 2 at the beginning. So the one that is negative 9 halves, negative 2 is C. So that would be our final answer for problem number 9. Okay, now we move on to problem number 10. Problem 10. It says, which of the following is the equation of a line that intersects y equals 4x plus 2? All right, let's see. So we say that intersects the line. Let's see. All right. Okay, now, I don't like how they introduced this problem because we have not talked about parallel and perpendicular lines. However, I'm going to explain this to you now. What happens is this here, parallel lines never intersect. Okay, now, I know you all have seen parallel lines. You have lines that are going in the same direction, but they would never intersect. For instance, this would be considered parallel lines. They would never intersect each other. These two here can be considered parallel lines. Now imagine that they are straight. These will never intersect each other. So basically they're asking you to find lines that will intersect that basically are not parallel. Now here is one thing you need to know about parallel lines. Parallel lines have the same slope. So if they have the same slope, the lines are parallel. Now in this case, what you would do for number 10, remember we did y equals mx plus b. So when you get y by itself, the number that's connected to x by multiplication is the slope. So basically, since we have in the directions y equals 4x plus 2, we know the slope here is 4. So if any of these lines slope is 4, that means we cannot use it. So any of the other equations that don't have a slope of 4, that means that they would end up intersecting. So let's look at A first of all. A, we had 2y equals 8x plus 2. Now remember, we got to get y by itself. So we would divide each side by 2. And that would mean each individual term here. So y is equal to 4x plus 1. This has a slope of 4. So that means we can't use A. Now we go on to B. If you look at B, it's already in y equals mx plus b form. If you notice here, this slope is 4, so we can't use B. Now we go to C. This is in y equals mx plus b form, but C has a slope of -4. So far our answer is C. So I'm going to write that down because it has slope of -4. So far our answer is C. But we're going to test D, which is 1/2 y is equal to 2x minus 7. So we got to get rid of this 1/2 off the y. So we'll multiply each side by 2. Because remember, this will be 2/1. These will simplify out and leave you y. So then you add 2 times 2x plus 2 times -7. So it'll be y equals 4x minus 14, which means your slope is 4. So we know when our slope is 4 that that's a parallel line, so we can't use D as well. So our answer here would be C. And this is it for lesson 10 for chapter 6. Have a wonderful day. And I will upload this to YouTube.